Computer programs need to know what kind of data they work with. Without data types, even something as simple as 2 plus 2 wouldn't be straightforward. The computer wouldn't know whether it should add two numbers together or glue two pieces of text. What I want to do in this video is look at the common data types and also the main reasons why data types exist. Let's dive in. Let's start by looking at an analogy. Here we have an airport luggage system. This is a simple system which has a conveyor belt down here, and it has 3 suitcases. 1, 2, 3. Each suitcase has a label. This one is oversized, this one is fragile, and the last one is regular. Now the airport luggage system needs these labels in order to handle the suitcases correctly. Now what does it have to do with computer programs, you might be asking? Well, computer programs also need some type of labels in order to process data the right way, and we call these labels data types. There are a few reasons why we need these data types. The first one is apply correct operation, then data interpretation, data storage, and lastly facilitating development. Don't worry if you don't understand any of them, we'll be covering each of them individually later in the video. First, I want to show you some common data types as well as operations that you can do with them. I'm not going to use any specific programming language because I want to focus on concepts first. If you know concepts, you'll be able to apply them to almost any programming language. Another thing to mention is that different programming languages have different type systems, and they have different names for types as well. Now we're going to define a few variables. If you don't know what they are, please watch my other video. Let's go back. Our first data type is int, short for integer, like a whole number 5. We typically use integer values for things that we can count. For example, apples on a table, number of houses on a street, number of stars in the sky. I hope you get the idea. Here on the right, we have a typical fitness tracking application. This application might have used integers for these two values, steps and flights climbed. And if you look at the code snippet here, we define a few variables and assign integer values to them, and then we perform some operations with them. Now in terms of operations, we mostly apply arithmetic operations on integer values, like here below. We have subtraction, multiplication, but you're not limited to that, you can do the others as well. Now let's go to our next data type. Our next data type is float, short for floating point number or a fractional number like here in the app. You can see the distance is expressed as a floating point value, 0.42. This data type is commonly used for measurements like height, width, distance, and so on. On the left, you can see how we use it in code. We have a float here that we assign to the variable, and then we perform some operation. In terms of operations, in addition to arithmetic operations as we saw with integers, we can also do rounding and others. In this case, we round the number 0.42 and 0 is assigned to the variable full miles traveled. Let's move on to the next one. Our next data type is unusually called Boolean. It got its name after famous mathematician George Boole. The Boolean data type can only hold two values, true or false. Sometimes they can also be 0 and 1. A useful way to think about Boolean values is that true can be thought of as yes and false can be thought of as no. We use Boolean values for things that have two states. Let's say we have a door, it can be either open or closed. Or you can say the weather is sunny or not sunny. Or as we have in this example, we have a bunch of checkboxes that can be backed by Boolean. If we look at this variable here, is pepperoni selected and draw an arrow over here to the pepperoni checkbox, we can see that it represents the state of this checkbox. Okay, how do we typically use Boolean values? By far the most common use case for Booleans is in conditional statements, like here. In this situation, we check the value of our variable. If it's true, then this block of code will be executed. In case you don't know, the block of code can be multiple instructions as well, but in our case we have just one. If the value of our variable is ham-selected word false, then this instruction would not be executed, and instead execution would go to the next line here. Okay, we've done half of the data types that we're gonna see today. Let's do the other half. I'm gonna go a bit faster now, as this video is already over 5 minutes, and I wanna cover some more important things later, the concepts that I showed you earlier. Okay, this data type is string. A string is just a bunch of characters or text. What's commonly done with strings is concatenation. Here we have two variables, they are strings, and we can combine them together into a larger string, John space Doe. In terms of operations on strings, you can usually get its characters, you can do slicing and other things as well. Let's move on. Here we have the type called object. In other languages you can find it by the name map, dictionary, or struct. An object is a collection of property value pairs like here. While before we had values like 5 or false, which were kinda atomic, with the object we have complex values to represent complex things like cars, airplanes, this form in particular. The most common operations that I can think of are assigning to a property and also reading from a property. If you need more time to look at this, please pause. Now let's go to the next one. This is our next complex type, it's called list. In other languages you can find it by the name array or vector, or others. Lists are used to represent collections of data, like here, for example. I'm not gonna go over the syntax, but here's how you'd define a list in our language, and you'd separate the values of the list by a comma. Typical operations that you could do with a list are add an item to the list, remove an item from the list, and then also iterating over the list. Please don't worry if you don't understand this. This is called a loop, and I'll be covering loops in detail later in my videos. Alright, now we've covered all of the types that I wanted to cover. Let's go to the reasons why data types are essential. Reason number 1, operations and functions. Let me explain. So here we have two operations, 2 plus 2 and also 2 plus 2. Notice that in this operation we have ints, or numbers, and in this operation we have two strings. And notice that we have the so-called operator or operation, the plus sign. Because the program sees which data type it operates on, it knows how to interpret the operation. In this case, it'll know that it has to add two numbers together, which will be 4. And in this case, because it has two strings, it will concatenate them, and the result will be 22. Now, sometimes in code you might have to do data conversion if you had the number 2 and the string 2, but it's beyond the scope of this video. Next, we have a variable c with the value John, which is a string, and here on this line we go c.round. This wouldn't work because round is not a valid operation. Round is not a valid function for this data type. But if we do slice, we'll be okay. We can conclude this section by stating that operator interpretation depends on data types, and also availability of functions depend on data types as well. Let's move on to reason number 2. Reason number 2 is data interpretation. Let's imagine we have two variables, a and b. The variable a is assigned a number 65, and the variable b is assigned the uppercase letter a. These values will typically be stored the same way in computer memory as the number 65, but in binary, as you can see in parentheses. I have an example of computer memory here, and we can draw an arrow from this 65 to here. It's stored in this cell, and we can draw an arrow from this a into here. We can see that it's also stored as 65, but it'll be in binary, as I said before. But when we then want to use these variables here and here, the correct data will be displayed for a, which is 65, and for b, which is a. And this will happen solely because of the data type information. Let's move on to reason number 3. Reason number 3 is data storage. The purpose of this section is to show you how data types affect how data is stored. On the right here, I have a simplified version of our computer memory, which is RAM. And I'm going to briefly explain this simplified version of how our data can be stored in this memory. The goal is for you not to understand every single detail, but show the principle that data types affect how data is stored. Let's begin. Our value 5 is stored in this location, and it occupies one cell for simplicity purposes. Our floating point number lives here in cell number 2, occupying one cell as well. The same is true about Boolean here in our simplified model. And here where it becomes a bit more interesting. With the string John, we have something called a reference. And I don't want you to freak out now. I'll be covering references later. But what I want you to know is because strings have arbitrary length, we cannot store it in one cell. And as you can see here, each character is stored individually in a dedicated cell. And the longer the string, the more memory will be occupied by it. A similar situation is with our object here. It is a reference value, which means that the cell itself doesn't contain the whole value of the object, and it just points to another cell. I forgot to mention that this star here, 5 star, it indicates that this cell points to another cell. In this case, it's 5 right here. In this case, it's 10. So the cell points to object data, and object data starts at location 10. And lastly, our list follows a similar pattern. It is a reference value. Again, don't worry if you're very confused. I'll be explaining this in more detail and much more slowly in another video. The objective of this slide is for you guys to understand that data types drive how data is stored in memory. That's it. Let's go to the next slide. Finally, we've come to the last slide. Reason number 4 is facilitating development. What does that mean? When software engineers develop programs, sometimes they can use the type information to help them build those programs. Here we have type number, Boolean, again Boolean, and some operation here to log a value in console. As you can see here, we have an identifier C whose type is Boolean, and we try to assign A to it, but the type of A is number. So the software where software developers build this program will notify them that this is incorrect. They'll see a message like type number is not assignable to type Boolean. And the same will happen if you try to apply operations to types that are incompatible. Lastly, what I'll mention is that programs will typically not compile if there are any errors like these two. Alright, if you're still here, thank you for staying with me. If you like this type of content, consider subscribing. In my next video, I'll probably cover reference versus primitive types so that you are less confused than today. And I'll see you there. Bye-bye.